Just give me a second. Okay. Well, also let's welcome Ting Amsel from the, I don't know, Google and Skywater 130 nanometer PDK and a lot of stuff. Ting is a man of anything. And Dr. Muhammad Kassan, I hope I pronounced your name right. And Dr. Iris from National Taiwan University, the very top rank university in Taiwan. So this is a panel that will be moderated by myself, and I believe that Muhammad Kassan has kind of a short presentation after our discussion with the panel questions. So without further ado, the first question will be: will EDA toolchain for ASIC become the next compiler that will one day become generally available to the public, and the open source way will be the dominant way for the EDA toolchain development?
I can start with the discussion here if you're interested.
Yeah, please go ahead.
I've been doing programming for quite a long time, and I remember back in the early 1990s where people used to use proprietary compilers for most of their work. If you think about back then, there were things like Boolean C++, Microsoft Visual Studio, and a whole bunch of other proprietary toolchains that you had to pay for. Sun had their GCC equivalent and these type of things. And then along came GCC. And GCC for a long time was worse than the commercial compilers. But now, if you came to me and asked me to use a closed source compiler for your language, I would probably tell you to go away, and I wouldn't even bother looking at your language. And I think this is shown by various things that Google is doing in the space. Things like Go, for example, have fully open source compilers. TypeScript has fully open source compilers. So I definitely think there is a real historic example of this happening in the software world. Maybe there's something different about hardware that will prevent this from happening, but I think it's very clear that in other places it has, and so it's only a time will tell type thing. I definitely think that there is a strong possibility this will happen. I don't think it will go. Proprietary compilers are going anywhere anytime soon, but definitely think that there's a lot of opportunity here for these open source silicon compilers.
So let me comment on this. I do believe it's a strong, it is not actually a strong possibility. It is inevitable. It will happen. And if you look at the development of chips over the years, there are categories where you have to intervene manually to optimize to the nth degree to get to the best process performance or other area or so. But the default or the typical settings, there is a large percentage of existing designs that you can actually get all the way through what looks like a compiler, like GNU. But it's not optimized the way you optimize it in a fully custom way. So we're missing all that. It didn't happen before because there are shackles around the availability of the process, PDK, for example, the cost of manufacturing, as well as the IP availability and the useful functions. With the RISC-V coming up, with the Power ISA coming out, with the PDK from Skywater, and probably the rest is going to actually pay attention, the rest of the foundries, to that because of the success and the traction that this has taken. The more pieces of the ecosystem get accessible, the more likely it's going to be like the software, and it's actually going to accelerate it. So IP will be developed, and that's happening already. Including libraries and included ideas about new devices. The software part it was actually incomplete. In the last few years, based on tool sets that are coming from different places, including the DARPA or the Open Road project, plus existing engines like USIS or other point tools, you will find that every piece has started to be more available. Again, the EDA, the cost of manufacturing is actually a result of that is going down, and the IP. Now, the last thing is actually knowledge, which once you open all this and make it available, people collaborate and complement each other and teach each other. So it is going to happen. It is inevitable. The question is, actually, you know, is it in the next few months or the next couple of years? But it's not going to be far beyond that for certain applications.
I understand. And I believe that Dr. Bloomingly have some insight on this, or hi, Dr. Lee. Oh, because Dr. Lee is actually joining another session on another track, so I guess he won't be very responsive. But anyways, Dr. Iris, do you have any comments on the first question? That is, this is translated from the question list I gave you before. I translated it into English, and it's just too vague, or?
I think for this issue, I would like to discuss for mature process nodes and advanced process node separately. For mature process node, we know that everything is going on and it happens. So for mature process node, I think open source EDA toolchain are under developing, and we all believe that in a very near future, a complete toolchain will be available. But for advanced process node, I think this issue is a totally different story. Because if we would like to have a toolchain for advanced process node, first of all, we have to understand the challenge encountered in advanced process. But for that part, as at the last for in second the whole environment, I think no foundry would like to release the challenge they are facing. So they will probably just provide some insight, but not the whole picture to everyone. So based on this limitation, for advanced process node, the complete toolchain might not be open sourced. They always are reached, but with very limited restriction and accessibility. So for advanced process node, so far I think the answer would be no. But for mature process node, I believe the answer will be yes. Thank you.
So actually, I'd like to comment just on that. Thank you very much. This is actually very true, the advanced nodes versus the mature nodes. I do think, however, that it is not, in my opinion, it's not a hard no. The reason is, for example, the Open Road project has been started under the hood on a 12 nanometer process. And it is a complete back-end tool set. It's not a complete flow, but it's a complete back-end tool set, placement, routing, that is started at 12 nanometer. So, but it is restricted. Not everybody has access to the PDK. So you'd have to have access to the PDK to get the benefit and actually be able to use it, to use the Open Road on it. So that will limit the propagation a little bit. However, I'm a believer. If I have an open source, if I have a 12 nanometer node that is open right now, I am almost certain if I'm not certain that it will be, people will be able to design with it within 6 months. Now the question is whether the designs are competitive in terms of area performance. That's a different vector. But can they design and create working chips? The answer is yes, given the infrastructure that is available today, including the open road infrastructure.
So I would also like to mention that the recent relicensing of the ASAP 7 open source PDK as from a non-commercial license to a real fully open source license is a big step forward to making open source tools work with these more advanced processors. Advanced processors also have some interesting properties about them. In many ways, they can be easier to target than these less advanced processors because it's much more restrictive in what you can do. There's an interesting project from Intel as part of the DARPA IDEA project that showed auto-generating layout for analog designs on a FinFET node like 7 nanometers is significantly easier than doing it on something like 130 nanometers, because on the FinFET node, the amount of restrictions you have of the type of transistors and shapes and layout that you can do is extremely limited. And whereas on like 130 nanometers, you have a lot more flexibility around like shaping transistors and, you know, all these weird types of tricks you can play. And so there's actually an interesting aspect that when you have a very strict set of rules, automated tools tend to be able to do better than when there's a lot more free-formness. And, you know, as we've gotten down the process nodes, the rules have gotten stricter and stricter in what you can and can't do. So I think that's kind of interesting. The other thing is just looking at the software world. Before I was working on this open source hardware, I was working on the Google Chrome browser. And for a long time in the Google Chrome browser, for things like multimedia codecs and other very high performance pieces of code, it tended to be handcrafted assembly by people. You know, people used to sit down and handcraft assembly for video codecs to make them as fast as possible. About 5 years ago, what we started to see was that modern software compilers were beating humans at this task. And, you know, it's increasingly becoming the case that because modern, you know, processors like CPUs are so complicated that a human can't take into account all the aspects of a modern processor to build performant code, that the machines have actually gotten better at doing optimization for CPUs than humans can. And in many cases, I saw in Chrome was that this handwritten assembly was being replaced with higher level code that actually turned out to be faster than the assembly that was supposed to be optimized for a human, because a computer doesn't forget about all the opportunities. It doesn't forget that weird instruction that, you know, shaves a couple of cycles off something. And so I do think there is a lot of potential here for the same thing to happen in the ASIC world, but we're still a long way away from that. You know, it took 15 years for the software, like the C compiler and C++ compiler, to get to a stage of just starting to beat humans. We've only just really started seeing open source compilers in Silicon. They're like a couple of years old. So we've still got another 15 years before we're beating humans. But I definitely think there's a lot of opportunity here, and I'm really excited to see what happens.
Yeah, and for beating humans. But so that's 15 years, because I was talking about 6 months and Tim was talking about 15. I think you can get designs done that are not open source using open source tool set in 6 months.
Yep, I definitely think it's possible. And GlobalFoundries 12 LP is probably the best supported process technology for the open road tools, because that's what DARPA required the open road tools to be evaluated on. You're probably not going to do an Intel, CPU with open road tools at the moment, but definitely microcontroller sized projects. The open road tools are starting to get competitive. Things like small RISC-V IoT level devices, open road is starting to be very good for. Still, that's a long way to go to get to Intel size processors and big things, but in 2 years, they've come a long way.
I see. Thanks for all the comments, but I need to address that this session has a very hard boundary on about an hour later, so we will need to fast forward to the questions. And the second one is open sourcing EDA toolchain for ASICs really helpful for people to learn, or it will be too complicated and people will just use it anyway without taking a look inside? So maybe
so I'll take a step on that. So actually, the way because eFabless, the way I work or we work in general is that design is design. Tools are designed to accelerate or accelerate the design process. So there are design steps. The design steps don't change. Now, if we have a compiler, there is a perception that the compiler will completely mask the knowledge required to know, for example, the back end and placement and routing. I say I come from a semiconductor background. I departed using 20 nanometer 10 years ago. So I'm very familiar with that world. And I do believe that when you are crafting, you need an expert to get into the detail to craft and use the process into its limits so they can get the process entitlement and the maximum juice out of the process. There is a whole new world, and I like to use Tim Ansell's expression and say, okay, I don't know what a DRC is, and I don't care to know what a DRC is, and 1 is equal to 1,000. I don't care, and I don't want to know, but I do want to make a chip. So the semiconductor industry, we're used to that micro level of detail that requires expertise to dig in, but there is a whole world that we're missing of a group of people that they don't want to know. They just want to get chips work. And they're not the same types of chips that are crafted by the experts. They're different chips for different applications. So I don't think that the open source tools will mask that, but it will make it possible because it's not shackled by the same commercial constraints, and it's supported by community that's hungry to make the chips available. That now, if you look an open lane or open road specifically, and I will show a picture maybe in the presentation, it is a flow. It has the standard design methodology steps that are performed using a proprietary system. So it is up to the user, and if I'm using it in education, I will focus on teaching the designers the design methodology versus the tools only, because that is the design. And then we have examples also from different universities that taught the design steps with different tools. So no, I don't think it's going to be an issue. It depends on how it's being taught. It's a choice.
Okay, thanks a lot for the comment from Mohammed. And I don't know whether Dr. Iris or maybe you have some comment on this, or you will just bypass the question. I'm totally fine with that, because this is a very open-ended question that might not have a concrete answer or anything like that. Yeah, please go ahead.
So I think for this question, actually, I think most universities start to rely on open sourcing EDA tools to help them to convey the idea to students. So actually, several courses start to include open source codes in their courses. So for learning, I think the answer is yes. So for the question, I think that there are two parts. The first part is would student would like or would people would like to learn how to use the open source tools, or would people like to learn how to design or how to develop open source tools? So for users, I think no matter but for both sides to learn or to use the open source tools still needs some training. So for to be a user, students or people can just attend some workshop to learn how to use the open source tools. And of course, for develop the tools in some university courses, the instructors start to design some labs or some training courses to teach students how to develop EDA tools based on this open source EDA tools. I think this kind of experience is very helpful, especially for those students who would like to join some EDA software company to design the core engines in those companies, or just students would like to start up some EDA companies by their own course. Yeah. So the answer definitely are yes. Yeah. Thank you.
Thank you very much for the kind comment. And Ting, I guess you have a lot to say.
Yeah, I just wanted to make sure other people got a chance to talk. I do want to say that having automated tools is really useful to get people started. But a good student and a good developer generally ends up looking inside their tools. For example, if you look at things like compilers, you can make a very simple compiler in a 6-month course. But if you look at like a modern LLVM compiler, you can have a 6-month course on things like register allocation all by itself. And you know, if you really want to become an expert in register allocation, you can. And you know, register allocation is super important for performance. And I think, or I hope, to see the same happen in EDA tool chains is that, you know, the good students, you know, go and ask, why is my tool putting the things a certain way, and then go and dive into it and can actually improve it. As well, I think we'll start to see the connection of people who are multidisciplinary. Google has this this idea that you take software developers and you add some other you know, field, like software developers plus chemist, or software developer plus doctor, like medical doctor. Software developer plus EDA, or like hardware person seems like a logical thing as well. And I think that will enable us to do some more interesting things that were previously impossible. And I've seen very smart students do things in code that, you know, people have said are impossible to do. And I think EDA algorithms also have this really nice aspect of being very similar to things that like mathematicians like to think about. There's lots of graph theory and, you know, distributed task solving. I think this is a really rich vein for people who, even though they may not be interested in EDA directly, would be interested in helping solve a lot of these problems that are currently locked out of the helping solve stuff, right? Like graph theory is, you know, a huge field inside computer science. So yeah, I think there's a lot of potential here for people to learn.
Okay, Dr. Iris, someone is asking questions on the YouTube, but I will fast forward to another question. Sorry, because we have a agenda to go. But if you want to answer this question, I will cross post for you because the system is not ready, and maybe you can reply to YouTube yourself, or I will cross post for you. And the third question is that, in what way should the governmental support play a role on such topics, and what's the benefit? Why should government do that? Because we're in a capitalism market that maybe we will just be a free market and let a free will design. I don't know. Anyway, so I'm curious that how Dr. Iris is commenting on will comment on this, because I don't know how to what level I can disclose your background, but anyway, I really would like to hear from you, because Taiwan is a powerhouse of fabrics and the foundries, but we don't actually have any kind of governmental support on this. So please.
Okay, so the third question. So far we know that US DARPA has a large project to support the open source EDA tools development. And in Taiwan, actually, we also have a similar type of projects to develop open source EDA tools. But it is very sad that the funding scale is totally different. So which means that we in Taiwan, the government funding is quite small compared with other countries or areas. So in Taiwan, I think we need more passions to do this. But no matter how in Taiwan, I think most EDA professors or researchers would like to be devoted to this direction, because it's promising, and we would like to make it happen in the near future. So no matter how small money we got, we will try our best to go this way. Yeah, but of course, if the government can support more funding to us, I think we can see that the result will be more promising than what we can see right now. Yeah.
So if you let me comment here, because I was born in Egypt and I grew up in Egypt, and then I was actually part of the looking at different countries like Brazil, for example, and then currently India, China as well. And it is actually a national decision. If a country wants to nationally stimulate movement, instead of dictating it, by putting facilitators or money or funding available for people to innovate resources. Open source availability, for sure, it's actually collaborative. So if you think about it, the DARPA output is global. So the Open Road project is being used. So there is the open source components here is going to be like the river that flows all over the world, and everybody will drink from it. It is important that the government takes, like for the DARPA doesn't make a business. So it is, when you mention the free market, it doesn't apply here, because the government does not intervene in the market. The government, if you think about it, they apply the funds, and they specifically apply the funds in this case to the crazy risk processes or technologies or developments that they're typically, people are not just going to go do it. So when a country does this, that's a strategic decision that will make a difference in 50 years. See how that country is innovative or not.
I think the one interesting thing we have here is that software development is a lot cheaper than a 7 nanometer foundry. the amount of money you need to attract a foundry to your shores and like have it, in your nation is quite a significant amount. If you took a small percentage of that and dedicated that to encouraging software development, I think you'd find that there's a significantly higher return on investment, especially if you've already invested in that foundry. A foundry that's sitting there and isn't, producing chips is a wasted investment. And so if you can put a small amount of money into software development that enables more chips to be created, you can make more money on that foundry and stimulate a lot more economic growth based on your investment in, having that foundry locally in your country. I also think that there's a lot of potential around these older foundries that are still available in many parts of the world that have been mostly kind of written off. These older 130, 180, or even 45, these foundries are struggling to find things to do. And I think open source would really enable these foundries to have a second life. And it doesn't take much investment to promote that. This is something that governments should look into. As well, there are a lot of companies now that are looking to invest in this area, and the government could work with these companies to get more bang for their buck, right? And the great thing about open source is it allows you to bridge those barriers that normally would be really hard from a legal perspective. Building a legal structure between, the government and 4 big companies is, a multi-year endeavor from a legal perspective. With open source, that can be done much, much quicker and much, much easier. And so, Google has been investing and providing funds to the Open Road project. We did that without having to ask DARPA anything. We just went ahead and gave grants to the people doing these developments, and they were able to accept it because we saw this as an important project. I'd love to work with more people outside of the US, but, I'm only an English speaker, sadly. I can't speak any other language. I have most connections with the US universities through things like the DARPA program. I'd love to have more connections with people in Taiwan. I definitely know Taiwan is punching above its weight in things like the EDA competitions. I frequently see you guys, winning things like placement competitions against, the top US universities. I see no reason why, Google's a global company. We shouldn't also be, partnering with groups in, places like Taiwan and Europe. I come from Australia. Australia is a really small country. We don't have the, ability to fund, billions of dollars worth of foundries. And so we definitely need to work together with other people. Yet we have a lot of interesting talent in the open source world. Australia has always punched above its weight in things like Linux and the open source world. So I definitely think there's a lot of potential here. The CSIRO at Google in Australia has always been at the cutting edge on some areas like, long reach fiber and CDMA, algorithms and stuff like this. So the government can, even if you're a small government, have an impact on a global scale through things like open source technology and through collaborations with groups in other countries.
Yeah, and again, once again, I will reiterate: open source destroys the legal need. It is actually the whole program since Google, got involved in, let's say, in the last year. That's 1 year. If you compare what happened in that 1 year compared to any other T0 to a key milestone, it's probably more than a 50x in terms of adoption as well as speed, velocity.
I like to say open source is kind of the grease that helps, things like economies and governments and people work together much more efficiently and quickly, and get more stuff done. And, there's a lot of stuff to get done.
Yep.
So there's no end of stuff to get done.
Yeah, I need to fast forward to the last question, and this is a long question, but I will cut it down to, it's very wordy. I'm so sorry that my English is not that well. In the core of, I want to ask just one question: that is it possible for for maybe a hardware company, but he doesn't know how to make their own chips? They know they have the they have some kind of Verilog or people like that who can do the analog circuit design, digital circuit design, but they don't know how to tape out, because tape out is a very long and complicated procedure. So if could they jump over the process that they can do directly go to foundry? And
so the answer is yes, and I'll just start that question just because it's open lane as in the question. The whole world grew up chasing the compute and smartphone to develop chips for these applications, because these are the highest volumes of chips in this area. And we would develop a chip with targeting 50 million units per chip, just because that's the aim for a phone. In order to do that, you optimize everything. We were negotiating the height of the package, so everything. Well, now that is not necessary for many other applications. Basically, the rest of the applications other than the smartphone and compute. Although the technology advances drove the smartphone itself right now drove a lot of good technologies like the sensing and the whole form factor miniaturization of the phone can be used now into the IoT applications in many ways. We have already, like with eFabless, we created a pick and choose, basically drop down menu based. I need that much memory. I need a CPU. I need this type of CPU. I need an encryption engine. I don't want to put my own. And then here's a bunch of analog. By the way, the analog now is getting into a position where it's a finite need. You shouldn't be looking for analog like a continuous spectrum that's never ending. Really, there are sensors, capacitive sensors, for example, resistive sensors. So you can categorize them and say, okay, I have 10 things that can apply to 80% of the chips. And you put them in a library. That's what we did. And you can go choose them. And then the tool, in this case, they don't build the analog. They combine them together. So at the ASIC level, yes, it's possible. We created an automated, and when I say we, I have to be very thankful to, we built it on top of an open source infrastructure. We didn't start from zero. That's an important piece. So we completed the last 5 miles. But speaking to the system developer that doesn't care what a DRC is.
Well, I'm not sure whether Dr. Iris or Tim will be commenting on this, because it's very open lane centric. I should choose a very bad question, but if you want to comment on this question, I will be love to hear from you people. That maybe Dr. Iris has something to say, or
yeah. So I think for the first question, the key concept inside this question is asking who will do the design service, who will do the design flow. So actually the RTL to GDS2 flow just like a silicon compiler. So for current practice, it will be done by some K guys in design houses or the whole team in design service company. And then if we have a complete silicon compiler, the complete compiler to go through the RTL to GDS2 flow, then actually the designer can be just a user of this flow or this engine, this compiler. So I think that for this aspect, the answer is yes. And but if if the target or if the content of the product is very complicated, then some maybe some kind of unexpected errors or warnings will be reported. Then at that moment, so who will be in charge of solving this kind of errors or warnings? So if the flow is very smooth, then I think of course it will be good. Yeah.
Yeah, and then the expression smooth, it actually, so we actually start by enforcing that it would be smooth and see what can be done within the smooth framework first. You'll find that you can do a lot. And then you can keep that as a bucket. And then you go to the other side and say, okay, I need very specialized chips with, with craftsmen or real digging into it to optimize it to the nth degree.
I do want to say that it's very easy to underestimate what a motivated high school student can do. There is a high school student called Sam Zieloff, who's now in university, but in high school, he built a late 1980s style foundry in his garage, pretty much from scratch.
Yeah, I see his Twitter post. He made a kind of amplifier chip, I believe.
It was like, I think 8 to 10 transistors. So, it's a very old technology, but still, this was something that a high school student did in their garage. And I have seen high school students, I've seen primary school students be introduced to FPGA programming and actually be able to do things with FPGAs that many people would say were extremely hard to do. And actually, it's really interesting. As a software programmer, one of the key skills you learn is this kind of idea that, the program does A, then B, then C in a kind of sequential manner. That kind of breaks down in hardware, right? Like in hardware, everything's happening all at once. It turns out because these primary school students haven't been taught this kind of, A, then B, then C, and had it like drummed into them, they actually can take to things like FPGA stuff significantly better than software programmers because they just assume that things happen at the same time. Why would A and B not happen at the same time? They're, two things just sitting there. And so I do think there's a lot of opportunity here for people who traditionally were thought of being unable to do these things, being able to do these things. And to even take this further, if you look at what a high school student can do in the modern software environment, it is amazing compared to what, the modern professional software developer could do, 30 years ago. 30 years ago, it was almost impossible to create a spell checker that could check, English language. Now that's a trivial thing you can do as, a primary school student, right? I think there's a lot of opportunity for the same to happen in the ASIC world with improvements in automation and stuff like this. And we're still really, really early on here. I think if you kind of think about where we are, we've yet to see the tip of the iceberg in what people will do in this space. For example, I was talking to someone about how analog computers are actually able to solve some equations that are almost impossible for digital computers to solve. And like they used to solve these back in the day using, you know, amplifiers and these type of things. I don't know if there's a future for analog computing because it now becomes much easier and accessible and cheaper to do. Maybe not. There's something I was talking about was we're hoping to add the ReRAM technology to this open source PDK, and this opens up a whole bunch of new ideas. Which ones of these ideas will be, you know, interesting? I don't actually know. And I actually think, you know, sometimes high school students and people who don't know how difficult things are have an advantage because they don't assume it's off limits, right? Like they go and go, well, I didn't know this thing was going to be hard, so I started it. Whereas like, you know, other people go, well, there's no way I'm starting that. It's going to be consumed like the next 5 years of my life to do. But, you know, people who don't know better start it, and some people are stubborn enough to get all the way to the end. Yeah, I definitely think there's a lot of interesting things that will happen here, and I don't know where it will go. And there's a lot of options here. I definitely think manual places and experts, you know, software experts, there are a lot of them still. Compilers haven't made software experts go away. So I don't think, you know, silicon compilers will make software, like hardware experts go away. They're still going to be just as needed. In fact, we're going to need more of them probably. And, you know, yeah, I'm probably rambling now.
Thank you all for answering these 4 questions, 4 very wordy and open-ended questions. And I believe that Muhammad, you have some materials want to show to us, or no, it will be just fine for now, because you asked me that
you mentioned that you saw specific material that you wanted me to present.
No, not exactly what. No specific materials, but because you just pinged me on the Skype saying that maybe you can keep.
Oh well, I'm gonna. There are a couple of comments here. Earlier, my colleague Tim Edwards, we were talking. There was a question about automotive.
Okay, I see.
So, and I agree with him, and also, I want to just elaborate on something. The whole what is it? The mystery of automotive, or what is it? It's certain quality metrics being applied to get things done. Well, and the tools are actually not the culprit in this case. There's the tools and the models, and the understanding of how the physics work at the high temperature or under the stressful conditions of automotive. If you have that knowledge, you will modify the tools to add the margin. You will modify the model to add the margin, and then typically the automotive doesn't just go to the cars. There's a lot of tests before then, so there are multiple safety nets to get there. And then once you do it and you qualify the methodology, then the methodology becomes standard, and you can actually go forward. It takes time. So the difference between your ability to do an automotive chip with an open source tools today, right now, is a function of your knowledge of that domain and what's needed there. I know at least 2 companies that are really close to me that are doing space and automotive with 100% open source tools chain. The difference is they know what's needed.
Okay. Okay. Sorry, I need.
That was my only comment. I just wanted to highlight that. I don't. If you notice, my entire theme is about it is possible, leaning towards the possible rather than it is not possible, and then it's going to be unstoppable within a short amount of time.
I see. Dr. Jiang, that there is a question on the YouTube. Will you be able to answer it, or just too harsh for you? I can just cut it out.
All right. So for the question raised by Elton, I would like to just briefly explain that. actually, all of us or everybody hope the foundry can release what kind of challenge or the detail of phenomenon they observed during their new process development. However, I felt that it's kind of a conflict of their interest or anyway, I think the practical burden or the practical stopper is that this is related to their trade secret. So somehow they would not like to release the weakness of their maybe weakness or just the challenges they faced during their process development. If they release this kind of information, then actually other foundries definitely know what the weakness, the point of this foundry. So kind of they would not like to release this kind of detailed information. But sadly, since they would not like to release this kind of information, it's kind of hard for us to help them to deal with this kind of challenges. Of course, definitely for personally, especially personally, I would like that they can tell us what kind of problem they faced. Then we can help them. However, kind of they would not like to release that to everybody.
So
that's
I believe that the foundries have no choice. Right now, there's TSMC, the largest foundry in the world. The second is 1/5 in revenue. Okay, and then Global Foundries and Samsung, and then so there's only one big foundry that is that big, and then the rest there's the two binary, there's like clusters of the UMC, the Global Foundries, and then everybody else. All of these people, all the rest of the foundries, they want their technologies to be used. So they actually have a different problem. For the technologies that they're good at, they can't find people to use it. So if they keep closing, they're going to have to make phone calls to find people to try their new technology. If they open and find a way to actually share, like something like what Tim was talking about, the ReRAM earlier, then more people will actually just use it. Yeah, just aside from the problem. Now, on the problem side, I say, okay, anytime the chip goes to production, I can take it and disseminate it. So the trade secret business needs to, it stops or it decelerates very big amount. Once there's a product, once I have a phone that has a 5 nanometer, it's expensive, but I can dig into it and I see the rules and I see how things are working. Not everything, but there's a lot of that gets divulged just by releasing the product. Now, it's expensive, still expensive. So I think my point is that agreeing with you, the foundries need to actually, semiconductor industry as a whole, need to get into the horse of openness means more innovation, means more competitiveness. That's the culture that needs to change. And versus holding, that's going to make me better. I think this is going to change.
Yeah, we will see what will happen. As I know that the TSMC started to release kind of information, but just partially release. So we will see how open they will be, and all of us would like to have more information related to advanced process. Then we can just
I think TSMC should release a lot of processes out and be confident about it to try this new experiment and see how it's going to work for them, because they are the most positioned to actually say we can afford it, to fail in it and correct for it. Now, that said, SkyWater is a very small foundry, and you can follow the results. I think that's going to make a big difference in just by following the results. Other foundries will move that direction.
If there's no other questions, then I will end the live stream now because it's just over this very over time for now. But I believe Tim have something to say, and I can maybe 5 minutes will be okay, or.
I just wanted to thank the other speakers for being on the panel and say it was interesting to get a non-Western perspective on this as well. I'm excited to see what happens in Taiwan going forward. And as I said, you know, Google's a global company and open source is a global movement. You know, Linux was started by a, you know, Finnish college student, and, you know, it's now used globally. So I definitely think there's opportunities for anyone, anywhere in the world. And as you have some of the leading foundries in the world, I think there's golden opportunities for Taiwan to play a big part in this. And so it's been really interesting to see what people have asked questions about and see what people's responses have been like. So thank you.
By the way, can we loop all the speakers in the mail thread, or is there any kind of... Okay, then I will send out an email thread and grouping all the speakers together.
And I think that's going to be a start. So
yeah. Thank you so much. Thank you, Dr. Iris. I know this. I know there's a lot of NDAs and a lot of trip water that you cannot touch. But thank you so much for coming. I really appreciate it. And I'm so sorry that to notify you in a so short notice. Anyway, thank you all.
Yep.
I will.
You've done a great job, by the way. So to stop saying sorry.
Okay.
Thank you very much.
Yeah, thank you.